Hi there, this is Ms. Page, and in this video we are going to learn about how to write a polynomial function when we have information about its roots, complex roots. So that will include real roots, rational and or irrational, and possible imaginary roots. So prior knowledge that we're going to be using in this is going to include this concept where we have done many times our algebra to find the zeros of a function. So once we have our factored form, we let our function value, our y value, be 0, and then we have a product of factors equals 0. We can set each factor equal to 0 using our zero product property, and then use our algebra to solve for the values of x, which of course are then the zeros. In this lesson, basically what we are doing is starting with information about the zeros. We will have to understand they are all values of x and work backwards towards creating these structures where we're equal to 0, and then on the other side will be the factors of the function, and then we can create our product of factors equals our function, here called f of x, and then multiply it all out if we need our standard form. So one of the things we've talked about in earlier lessons that we also are going to need to use is our complex conjugate root theorem. And this tells us, this we have to be aware of because these problems, to test our understanding of this, will often only give us one of a pair of conjugate roots. So for example, we might just be given 3 plus the square root of 2 as a root. But we have to understand, based on this theorem, that we would also have to include 3 minus the square root of 2 as a root. We also might just be given 2i as a root. And then we'd have to understand from this theorem that we'd also have to include negative 2i as a root, or 0 of the function. And that's where we'd actually start these problems. So these are the steps, and as I said, what we have to do is determine if we have any additional roots using our conjugate root theorem. That would include missing roots for irrational or imaginary situations. Then we'll have to use our algebra to work backwards to find the factors that each root came from, and then we will write our function as a product of factors multiplying the factors then together using our distributive property to get our function here called p of x in its standard form. All right, so let's take a look at a problem. So again, here our instructions say we're to write a polynomial function called p of x. So that means we have to start our answer with p of x equals. It says of least degree. That means that we include all of the values of x that we know for sure are roots, but we don't add any additional roots to the problem, and we want it to be in standard form. So that means that it has to be all multiplied out. It can't be a product such as factored form. All right, so we are told here in this particular problem that we know we're given that this particular function has the root of square root of 2 and negative 4i. First off, what we need to realize is negative 2 is, of course, irrational, and so it has to come in a pair. And negative 4i is imaginary, and it also must come in a pair. So we have to figure out what the other part of the pair is. So they're complex conjugates, meaning that the first terms are the same and the second terms are opposites. In these pieces, our real part would both be 0. So this would be like 0 plus the square root of 2, which means that its conjugate would be 0 minus the square root of 2, which would simplify to negative square root of 2. So we have positive square root of 2 that's given, and negative square root of 2 that its conjugate pair. Negative 4i would become from 0 minus 4i, so its conjugate would be 0 plus 4i. So that means we're given negative 4i, and its conjugate pair would be positive 4i. So these are all of the roots that we know we have for this function. We wouldn't add anything additional to it to keep it at a least degree. So now we need to do is figure out what factors these came from. So each one of these, remember, is a value of x, a root or 0 of the function. So we start by understanding that, and now we're going to use our algebra to work backwards to get a 0, a number 0, on this right-hand side. So I would subtract the square root of 2. And that gives me x minus the square root of 2 equals 0. So we haven't seen factors that look like this before because we've always used other algebra methods. In the quadratic form, we've used the square root property to get to this. But this is the factor, the linear factor, that this particular root comes from. And so that's what we're going to use. And then here we'd add the square root of 2 to both sides. And we get x plus the square root of 2 equals 0. So x plus the square root of 2 is the linear factor for that root or 0. Here we'd add 4i, giving us x plus 4i. Again, a type of factor we have not seen before. It's a linear factor for an imaginary root or 0. Usually we stop at the quadratic and use our square root property. And then here we've got x minus 4i equals 0 for another linear factor with an imaginary number in it. So now we have all 4 factors of our function. And so now we're going to write our function in its factored form. So remember, it's named p of x. So we start with p of x equals. And then you can write your factors in any order you want to, but I do recommend that you put the conjugate factors next to each other. So I'm going to write x minus the square root of 2 times x plus the square root of 2. And then I'll write times x plus 4i times x minus 4i. Now technically we could multiply these together in any order we want to, multiplying 2 at a time. But it will be easiest, mathematically speaking, if we multiply the conjugate pairs together first. Because when you multiply conjugates, your middle terms will be opposites of each other and add up to 0. So what I have now, so I write p of x equals, so this would give me x squared. I get a positive root 2x and a negative root 2x, so that adds up to 0. And then I have a negative square root of 2 times a positive square root of 2. That would be negative square root of minus the square root of 2 quantity squared. And the square and the square root undo each other, which gives us x squared minus 2. You can also look at that, remember, as the square root of 4. And the square root of 4 is also equal to 2. So that product simplifies to x squared minus 2. And this is the factor we're actually used to seeing that gives us the roots or zeros of positive and negative square root of 2. Similarly, over here, we have x times x, which gives us x squared. We have a negative 4ix, and we have a positive 4ix, so those add up to 0. Then we have a positive 4i times a negative 4i, which should give us a negative 16i squared. Remember, I squared is negative 1, so we have a negative 16 times a negative 1, which would be a positive 16. So this factor simplifies to x squared plus 16. And now, finally, for our last step, we would multiply these two binomials together. So we get p of x equals x squared times x squared would be x to the 4th. We get a positive 16x squared plus a negative 2x squared, so that's a positive 14x squared. And then negative 2 times 16 gives us minus 32. And there's our function that had the roots we were given as well as their conjugate pairs. All right, let's take a look at another one. All right, so for this problem, here we see we have all of these roots. Now, for this problem, what we need to realize is that negative 6 is rational, 5 is rational, and 3/5 is rational. Rational roots or rational zeros do not come in conjugate pairs. It would be wrong to do a conjugate pair here. So these are all of the zeros that we're going to have. No additional zeros. All right, so that means we will now start by letting each of these zeros or roots, as they're called here, be, of course, their values of our variable x. So we know x equals -6, or x equals 5, or x equals 3/5. All right, so here with this one, we'd add 6 to both sides, giving x plus 6 equals 0. So x plus 6 is a factor. Here we'd subtract 5, giving us x minus 5 equals 0. So x minus 5 is a factor. For this one, don't subtract 3/5 from both sides. You can, but that's not all you need to do, because you need your function to be in its simplest form, which would mean integer coefficients, not fractional coefficients and numbers and constants. So what we're going to have to do is remove our fractions. So personally, it's easiest, in my opinion, if we first undo the division, which, remember, this means 3 divided by 5. So undo that by multiplying both sides by 5. And that gives us 5x equals 3. And then subtract 3. So the factor we should be using is 5x minus 3, not x minus 3/5. So now we have all of our factors. We will now write our function in its factored form. So our function is still p of x equals. You can write the factors in any order you want to. Does not matter here. There are no conjugate pairs. And now you have to multiply 2 of them together first. Your choice, of course, which 2 you multiply together first. If I'm going to multiply these last 2 together first, so this would be 5x squared. Negative 25x and negative 3x would be a negative 28x. Negative 5 times negative 3 is a positive 15. Now I have to multiply that times x plus 6. So x times 5x squared, I get 5x cubed. Continue to distribute the x, I get minus 28x squared plus 15x. And then distributing the 6, I get plus 30x squared. 6 times a negative 28, let's see, that's 48. 12 and 4 would be so negative 168x. And 6 times 15 would be positive 90. Don't forget, when you're doing more complex algebra like this, that you still need that p of x equals to be writing a function. And then combining like terms, we get 5x cubed plus 2x squared minus 153x plus 90. So there's our final function. All right, and moving on. So here we have a third example. This one, we are looking here at our roots. So what we need to realize first is the root or 0 negative 2 root 3 is irrational. So it is part of a conjugate pair. Negative 4 is rational and 3/2 is also rational. So they are not parts of conjugate pairs. So in this case, we do need to figure out the conjugate pair of negative 2 root 3. So again, its full form would be 0 minus 2 root 3. And so its conjugate would be 0 plus 2 root 3, which would give us a positive 2 root 3. So we have negative 2 root 3 and we have positive 2 root 3. It's conjugate. And then we have negative 4 and only negative 4 because it's rational. And we have 3/2 and only 3/2 because it's also rational. So those are all of our zeros. So now we're going to find the factors that each one of them came from. And so here we're adding 2 root 3, so we get this x plus 2 square roots of 3 factor. Again, not the type of factor we're used to looking at, because we usually use the quadratic factor and the square root property to solve. But here this is the linear factor it would come from. Here we'd subtract, so we get x minus 2 root 3 equals 0, so x minus 2 root 3 is that factor. Here we'd add 4 to both sides, so we get x plus 4 equals 0. And here we have that fractional situation again. So we don't want to subtract 3/2 or only do that. We have to get it into its linear form where it has integer numbers in it, not fractional numbers in it. So multiply both sides by 2, which gives us 2x equals 3. Then subtract the 3 from both sides, which gives us 2x minus 3 as the form of the factor that we need to use here. So now we have all of our factors, and we're going to write our factored form of our function. So again, p of x equals. Now the order of the factors, again, does not matter, but I would put the conjugate factors next to each other. So I either put them as the first two factors or the last two factors, or I guess I could put them as the middle two if I wanted to, but probably best to do first two or last two. All right, so I would multiply these two together and these two together as my next step. So I have my p of x equals, this is going to give me x squared, and this is going to give me a negative 2 root 3x plus a positive 2 root 3x, which would be 0. Be careful with these last factors, so it's often best to do them in parts. So do your sign, positive times negative is negative. Rational 2 times 2 would be 4, and then square root of 3 times square root of 3 would be the square root of 9, or the square root of 3 squared, which both would give us 3. So this is 4 times 3. So simplifying, we actually get x squared minus 12 as that factor in its simplest form. Here, we're multiplying these two binomials together, nothing special about them. It's going to give us a trinomial because they're not conjugates. So we have 2x squared. We have a negative 3x plus an 8x, that's plus 5x, and then minus 12. All right, so now we have to multiply our binomial and trinomial together. So I'm going to distribute the x squared first. So this is going to give me 2x to the 4th plus 5x cubed minus 12x squared. Now I'm going to distribute the negative 12, so this is going to give me negative 24x squared, so I put it here, minus 60x plus 144. And again, at this point, with this more complex algebra, don't want to forget we have p of x equals, and then writing our standard form, 2x to the 4th plus 5x cubed minus 36x squared minus 60x plus 144. And there's our function. So we can see we have problems where we have roots that are all either irrational or imaginary. So we have to figure out their conjugate pair root. We can have roots where they're all rational roots, so we have no conjugates going on. And then we can have a mixture like this problem where we had one irrational, so it had a conjugate, and we had two rational that had no conjugates. So we have to be on the lookout for all of that. All right, here's a practice problem. You can pause here, try this one, and then we'll take a look at the result. All right, let's take a look at our answer. So this one, all of our roots are rational, so there's no additional roots. Setting those equal to our x and solving backwards to figure out our factors, we get x plus 4, x minus 3, and 3x plus 2. Here's our factored form. This one multiplies these two together first, and then doing the final multiplication gives us this function. Let's look at another practice. Pause your video here. All right, let's take a look at the result. This one, this root was imaginary, so it has a conjugate. That conjugate is actually written right there. And this root is irrational, so it has a conjugate, which is written right there, negative square root of 5. So we have 4 roots, 2 imaginary, 2 irrational that are conjugate pairs. So working backwards, we get these 4 linear factors. Here's our factored form, multiplying the conjugates together first. These two conjugates give us x squared minus 5. These two give us x squared plus 25. And then the final distributing gives us that function in its standard form. All right, let's take a look at a third practice. pause your video here. All right, let's take a look at the result. So here you have to realize you have a mixture similar to our last example. So we have 2, which is a rational root, so it does not have a conjugate. But we have negative 3 root 2, which is irrational, and it does then have a conjugate, and that is a positive 3 root 2. So we have 3 zeros. Working backwards gives us these 3 factors. Here's our factored form. We should multiply those conjugates together first. When we multiply those conjugates, we get x squared minus 18 as the factor in its simplified form. And then using our distributive property on that and the x minus 2 factor, we come up with this function at the end. All right, so that finishes this problem or this lesson with all of its examples and practice problems. You guys have a great day.